So now let us look at some examples. So I want to evaluate each definite integral. So part A, the integral from 1 to 2 of x squared minus 3 dx. So if we're using the fundamental theorem of calculus, we just need an antiderivative of this function right here, x squared minus 3. So can you think of a function whose derivative would be x squared minus 3? Well, x cubed over 3, if I take the derivative of that, that would be x squared. And the derivative of 3, you would want a function who had derivative 3, so 3x. So from 1 to 3, so we're going to plug in. Fundamental theorem says plug in the top number first, 3 cubed over 3. Or sorry, not 3, 2. Should have been a 2 here. Plug in the top number first, so 2 cubed over 3 minus 6. And subtract, plug in the bottom number, 1/3 minus 3. So it looks like you're going to get, if I combine these first two, you'll get 7/3. And then if I combine this one here, remember there's this minus, so it's really a plus 3. You'll get a negative 3, which will be a negative 9 over 3, or a negative 2/3. All right, and then let's look at another one, B, the integral from 1 to 4 of 3 square root of x. So the first thing we can do is pull out this coefficient of 3. You can pull that out in front. So this will become 3 times the integral. And square root of x, that's the same thing as x to the 1/2. So can you think of a function that has derivative x to the 1/2? Well, x to the 3/2 almost has the correct derivative, but I've got to divide by 3/2 then. Okay, so I'm getting, really this is the same thing if I simplify the coefficients as 2x to the 3/2 from 1 to 4. So this will be 2, 4 to the 3/2 minus 2. And 4 to the 1/2 power is 2. So this is 2 cubed. So 16 minus 2, or 14. And there's my answer, 14. Let's look at one more. Part C. The integral from 0 to pi over 4 of secant squared. So think about your trig functions. Which function has derivative secant squared? It's tangent. And then using the fundamental theorem of calculus, it says plug in the top number minus the bottom number. Tangent of pi over 4 is 1. Tangent of 0 is 0, so this is just going to be 1.